Hello everyone. The topic of my presentation is blockchain technology for 5G and 6G networks. These are the contents. First one, we will talk about introduction of blockchain. After that, its characteristics, then components of blockchain, how the blockchain works, blockchain in 5G networks, blockchain in 6G networks, and finally we will conclude the presentation with the issues and problems in blockchain networks. So coming to the introduction of blockchain. Blockchain is a distributed ledger in which the information is stored as a chain of data blocks. It is a technology which allows the data to be stored and exchanged on a peer-to-peer basis. The blockchain data can be shared, consulted, and secured. It is in a decentralized manner and removes the need for intermediaries or trusted third parties. When a block has been validated, it is added to the blockchain and shared with the network. Blocks are connected to each other in such a way that if any user wishes to change one block, then that is not possible, and the entire blockchain must also be changed. Decentralization, reliability, anonymity, transparency, auditability, and programming are the characteristics of a blockchain. Talking about the components of blockchain, these are the database, application software, the number of computers connected, customers accessible, software environment to develop on it, and tools to monitor it, and other pieces. By this diagram, we will try to understand the working of a blockchain. Suppose A and B are the two nodes in a blockchain network, and user A wants to send money to user B. The transaction is represented as a block initially, and the block is broadcasted to every node in the network. After that, the sufficient miners approve the transaction using the complex mathematical problems solution, and the transaction is added to the blockchain. And finally, the user B receives the money. Now, blockchain could have several applications and uses in the 5G and 6G networks. So, we will first cover about the blockchain usage in 5G networks. The blockchain plays an important role in the 5G network, and there are several blockchain-enabled technologies such as authentication, access control, spectrum management, uses of blockchain in software-defined radio with the 5G, and several applications like vehicular network and edge computing. These blockchain enabled technologies, applications, and services consist a part of 5G network. First one, we will talk about authentication. So a new efficient lightweight blockchain enabled RFID based authentication protocol called LBRFPS is proposed that could be used against various attacks in 5G IoT environment. LBRAPS is based on a XOR or bitwise exclusive or one-way cryptographic hash and bitwise rotation operations only. Blockchain-based robust and universal seamless handover authentication protocol named RUSH could also be used in 5G heterogeneous networks to process the anonymous mutual authentication with a key agreement. Another blockchain-based authentication scheme is there in 5G networks that is also in a consideration, which may reduce the authentication frequency when devices move among the access points and improve the access efficiency. Moving to the next part, that is access control. Access control is defined as a process which mediates every request to resources and data maintained by a system and determines whether the request should be granted or not. Connectivity platform named Paladin Bandwidth Ledger Accounting Networks could be used that combines the consortium blockchain with access control mechanism to solving drawbacks of communication Wi-Fi and ad hoc networks. Blockchain-based framework that could be deployed in the healthcare area also, which utilizes smart contracts in an Ethereum-based blockchain for the increased access control of data. Blockchain enabled decentralized capability named Blend CIC that could also be used to achieve the effective access control processes to devices, services and information. Now verification. So the blockchain based verification method is used for two purposes. The first one is for financial transaction and the another one is for data integrity purpose. For the financial transaction purpose, new distributed and secure data sharing framework named device to device blockchain is introduced that could verify end users transaction via the set of access points in 5G network. For the data integrity aspect, a blockchain-based architecture is presented that could verify the data integrity that is produced by Internet of Things devices, even in the perspective of cyber physical systems, that is CPS. For the spectrum management, the blockchain can be used also. A virtual currency named SPECoins that could be used for payment to access as spectrum under an auction environment. A spectrum sensing service named SPAS that could enhance the spectral efficiency based on a smart contract payment mechanism running on a blockchain. Also, there is a proposal for a trustworthy spectrum access system named TrustSS, and it could be used to enable seamless spectrum sharing between secondary and primary users. For the software-defined network domain, some limitations are there in software-defined network domain that have been explored in the field of 5G networks, such as the security and scalability. The blockchain-based SDN technology comes into picture here. Blockchain technique named block control that could improve the security of control plane SDN could be used. Another blockchain-based framework named Chain SDI that could share sensitive data securely also could be used. SDN data chain based on blockchain that could reduce the cost of network failure recovery and achieve the unified scheduling of business capabilities is also proposed. Now we will talk about some of the applications and services via blockchain in the 5G networks. The very first one is the smart transport. So the vehicular network is one of the most important aspect in 5G networks. So as the data stream is getting bigger and bigger in the vehicular network nowadays, the pressure of traditional centralized management and data storage is followed increasing. Blockchain technology could meet this requirement well by deploying the blockchain technology into the vehicular network. Not only it decentralizes but also significantly improves the security of a network. A blockchain-based distributed software-defined vehicular ad hoc networks framework could be established a secure architecture to prevent the decline of performance caused by malicious attacks. And with the managerial responsibility shared between the blockchain and the software-defined network, the pressure of the controller is significantly reduced. In the field of the smart industry, blockchain-based data sharing mode could also significantly increase the security level of the transparency and credibility of stored data. Blockchain-based distributed consensus mechanism named BHRAFT chain is proposed for solving the problem of device collaboration in industry. Another blockchain-based system named BSELN for secure mutual authentication, which could be used for enforcing fine-grained access control policies. For the Internet of Things, the combination of blockchain and 5G IoT could significantly empower the IoT services and applications. The blockchain technology could encrypt data at its sources and protect it through its life cycle in Internet of Things scenario. Blockchain-based smart home framework could significantly improve the security of core components and functions of the smart home tier. Another blockchain-based IoT framework named Blockchain of Things would have several benefits such as interoperability across IoT devices, traceability of IoT devices, their reliability, data, and autonomic interactions of IoT systems. Blockchain technology here also could be used in managing device configuration, storing sensor data, and enabling micropayments. Now we will discuss the uses of blockchain in 6G networks and its application. The 6G network could not only be faster than 5G but also it is fully deployed artificial intelligence inside. The blockchain enabled technology should consider the spectrum sharing and blockchain with AI. For the application and service, it should consider the distributed ledger technology, edge artificial intelligence, and the Internet of Everything. For the spectrum sharing in 6G, the blockchain could represent the centralized database in a spectrum sharing system. This could significantly increase spectral efficiency. The smart contract technology in the blockchain could alleviate the spectrum sharing related cooperation and transparency issues. Blockchain based protocol is presented for enabling and securing spectrum sharing, which realizes an auction mechanism based on a first come, first served queue to let each primary user advertise their spectrum in a decentralized fashion. This auction method greatly increases the spectrum sharing efficiency. Blockchain could also be used with artificial intelligence. Blockchain technology could combine with deep learning and they together solve data security and transparency issues. Blockchain based AI techniques can offer decentralized learning to facilitate the sharing of knowledge and decisions between the different agents, which would be used in a 6G network scenario. Here are some of the applications and services provided via blockchain in 6G network. So first one is the distributed ledger technology. So the combination of blockchain and distributed ledger technology could be considered as the next generation of distributed sensing services, which could ensure the low latency, reliable connectivity and scalability for the 6G networks. Also, the combination of these two could be used in the scenario of smart cities, sharing economy and social compliance for 6G networks. And by deploying the blockchain-based distributed ledger technology, the 6G security for the network could be improved significantly, especially for the surveillance and governance of the 6G networks. For Internet of Everything, the future 6G IoE networks, they are not only connect people but also devices from the computing resources, vehicles, wearable sensors and even the robotic agents. By deploying the blockchain into IoE, the data could be stored securely and shared through distributed blockchain (DBC) transactions and protected by consensus protocols and cryptographic security. And there is no need of entrusting any central party of the ledger maintenance. The blockchain technology could improve the interoperability, privacy, reliability, and scalability of the underlying infrastructure in Internet of Everything networks. Blockchain-based reward mechanism that the devices in the IoE network could share their power or data to get the corresponding reward. It could make the environment of the network more collaborative and trusted. Blockchain could also be used in vehicular to anything V2X communications to encourage vehicles to trade energy or information with each other. Also, there are some issues and problems in the blockchain networks, which we will discuss now. The very first one is the distributed denial of service DDoS attack. The DDoS attack is another possible attack that would have a great impact on the security of the blockchain networks. This is because the blockchain design is based on the peer-to-peer architecture, and its openness will lead to DDoS attacks. The nodes in the different position of the blockchain networks could jointly launch DOS attacks to hinder the normal operation of the entire system. Scalability problem. So the poor scalability is a problem that the blockchain needs to solve on urgent basis. Due to the decentralized character of the blockchain, some applications of blockchain networks need high computation resources, bandwidth, and storage to ensure the integrity of the distributed ledger. When deploying the blockchain in future 5G and 6G networks, there's a huge amount of like billions of smart devices and their massive transactions requirements would become a great challenge for the scalability of blockchain networks. Now there is also an issue with the quantum communication problem. The quantum communication problem is one of the most promising technologies which would be used in 6G networks. When using these quantum algorithms such as Shora in blockchain network, it is possible to break the RSA encryption. Factoring and discrete logarithm based cryptographic primitives such as elliptic curve signature algorithm also become vulnerable because of deploying large scale quantum computation. So that's all about my presentation, and these are my references. Hope you like the video. Thank you.